Hey there, grade 11s. So today this lesson talks about the last part of the Analytic Geometry booklet that we've got going on. It links up with the other video, and it talks primarily about something called the trans-dimensional analysis, or what we call the shadow effect. And so we'll be solving some inequalities, algebra inequalities by hand using algebra. And then we'll look at how the graph helps us answer these questions. And you'll see what I mean by the shadow effect. So let's get started. Okay, so I've chosen this example here as a nice introduction to the idea of the shadow effect. And yeah, so let's get started with solving this. This is just a standard regular algebra question. Well, it's an inequality question, so there'll be like regions that are true and false. So let's have a look and see how this plays out. Okay, so we just start solving just like a regular algebra equation, add 4 to both sides, and then I get, 2x is greater than or equal to 4, right? So, or sorry, 4 is less than or equal to 2x, so I'm reading this in a mirror, and just solving, so I divide by 2. Okay, so I get 2 is less than or equal to x. If I write it the other way, x is greater than or equal to 2, and there's my solution. Okay, and if I think about that on a number line, right, everything greater than 2. So here's 0, 1, 2, and everything greater than. So everything in that region. So this would be like the shaded region of the number line that would indicate the numbers that make this equation true. So let's just keep this in mind as we look at the shadow effect, because that's something that's very, very interesting and incredibly powerful. Not only in mathematics, but also in things like psychology as well. Okay, so if you look here, right, these two are very similar. The only difference is that's the 0 and that's the letter y. So similar to what we did in the last booklet, I mean, I can graph this in 2 dimensions, like I'm adding a dimension, I'm adding a parameter or variable here, right? So this is one parameter or one dimension, value x. This says x and y, so it's 2-dimensional, which we can graph. So let's graph this particular inequality and see what comes out. Don't forget we have our solution from the from before. And I'll just keep that up in the corner to remind us of how this kind of what our end result should be. So let's have a look. Right, so there's the line y is equal to 2x minus 4, and then we've got to think about, okay, do I shade above or below? And this symbol is a less than symbol here, so that means it's going to shade below the graph. All right, let's have a look. Okay, so there's my shaded region, right? As per usual, like, okay, so what, right? What does that mean? Does that mean anything? Well, it kind of does, because if I look here, right, I've got y equaling 0 if I wanted to connect these two equations. And so where's y equal to 0? That's the x-axis. So let's take a little snapshot of what's going on the x-axis. Can you see where this is going? Have a look. Okay, so there's the x-axis where y is equal to 0, right? I know some people might forgot when y is 0, all the y values on the x-axis have 0 values. So this would be like the point 1, 0, 2, 0, 3, 0, and most of the y values are 0. So this is your y-axis, and where is it shaded on the x-axis where y is equal to 0? Where is it shaded? When x is bigger than 2. Dun, 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 dun. There we go, right? We have a shaded region where x is greater than 2. Any value in this region on the number line will make this equation true. And that's what we said it would be when we solved it by algebra, right? But here, check it out, right? What I've done is I've taken a one-dimensional equation, added a dimension and graphed it, and then brought it back down to a one-dimensional analysis on the number line, and I get the same answer as what I had at the beginning. That is incredibly mind-blowing, because here we're working in 1 and 2 dimensions. But you can apply this to 2 and 3, 3 and 4, 4 and 5. You can go up the dimensional ladder quite far. And I know it's hard to visualize, 4, 5, 6, 10, 12 dimensions or parameters, but we have math for it, right? We have the math to be able to understand what's going on up there. And this even applies to things like psychology. If you understand a little bit of psychology in the shadow, the nature of the shadow, right? Well, where does our shadow come from? It comes from our higher dimensional selves. And that's out of C.G. Jung. If you're interested in studying that, I'll write that down. C.G. Jung. If you're interested in learning about that aspect, because I know some of you guys are psychology people, and so if you're interested in learning about the shadow effect in psychology, look him up. He's got the ideas going on. So let's have a look and see how this plays out with a little bit more complex ideas, okay? Okay, so let's do this by the book, right, and solve it properly. So it's an absolute value question. We split it into two parts, as per usual. I'll write you a little T-chart so that you can see how this works. And then let's solve it by analytic geometry, which is the bomb. Okay, let's have a look. Okay, so we make it into an equality. Okay, no problem. That's an equal sign. So we have to solve for the 2 points, you know, split it apart, etc. Right, we try to figure out what makes this bracket equal to 2, because the absolute value will make it a 2, and we try to figure out what makes this bracket equal to negative 2, because when we do the absolute value, it makes it positive 2, right? So we've got to split it up into two groups and solve. Okay, pretty easy solving, I suppose. So my solutions are x is equal to 1 and x is equal to negative 3 for the equality. But remember, we're talking about an inequality, right? So there's going to be shaded regions. And so I need to figure out what those shaded regions are, and I need to do that on a number line. Okay, so number line. Okay, so there's my numbers on the number line, and I have region 1, region 2, and region 3. And I don't know which regions are true, so I have to go back to the old idea of testing points. So I need to take a point and test it. So over here I could test negative 4 and see whether I get a true or false statement up here. And let's see what we get if I use negative 4. So when I test negative 4, right, I get negative 3, absolute value makes it positive 3. Positive 3 minus 2 is 1. So I've got a statement that says 0 is greater than 1. And that's false, right? So here in negative 4 over here, this is the false this is a false region. So I have to do another one. Let's try 0. Let's see what we get there. And I'm just going to erase this one. I'm kind of running out of space. And let's test 0. Okay, see what we get when I test 0. I just plug it into the x value, right? Okay, and so when I test, I get a statement that says 0 is greater than or equal to minus 1, right? I just stick in whatever I'm testing up into the x value and see whether I get a true or false. And this is indeed true. So that means this point is true and all the other parts there as well. And you can go ahead and you can test all the different regions. So this is true. If you test this one, it winds up being false. So the only region that we have that's true is between negative 3 and 1. And I would write that like this. X is between negative 3 and 1. That's how I would write that notation without just showing it on a number line. So okay, it's a lot of work, right? I mean, you got to solve it. You've got to plot it on a number line. You got to test all the regions. Sometimes it doesn't always alternate. Sometimes it's 2 in a row and then one doesn't. Like, it's not entirely clear unless you test. Now you can go through and test at this point. You could like test point number 2, right? And you get you get a false statement there if you tried that. So we get this situation, right? And there's our answer. A lot of work, not very fun. So let's use transdimensional analysis, the shadow effect. And you'll see it's much quicker. Let's have a look at that. We'll just keep in mind our answer down here, okay? Okay, so I got a little T-chart. We know what our answer is up there from before, so I'm going to use the transdimensional. All I'm going to do is I'm going to change that 0 to a y and then graph it out. So I'm going to expand the dimensions from 1 dimension with just an x to 2 dimensions with an x and a y. Let's see what happens there. Okay, so expand the dimension by letting 0 equal y, so I'm changing that 0 to a y. Now I have an equation. You guys just finished doing a bunch of equations like that. This is pretty easy, so let's graph that sucker. Right, so that's what the equality looks like. Your vertex is over here, right? -1, -2. You can see that right there. And now all we have to do is worry about shading. So this is y is greater than. So greater than means above. So I'm going to be shading above. Let's see what that looks like. Okay, so shaded region right above. There we are. Now, see what I've done is I've expanded from 1 dimension to 2 dimensions. Now let's have a look at what's happening back when y is equal to 0 or back along our x-axis. Interesting. Okay, we're going to examine the shadow where y is equal to 0. Where's the shading going on? Well, it's exactly what we did in the last example. Right, if I took a snapshot off my x-axis, -3, -2, -1, 0, and 1. So I'm shading between -3 and +1. Is that not what our answer was right there? Right, if I think about that, that's x is between -3 and 1. Is x is between -3 and 1? Yeah, it is. And that's why this is off. Boom, there's my answer. Now, if you think about the two methods, right? The last one, if you scroll back a bit in the video, where you had to like solve it and then plot it and then test it, and oh my gosh, your head's like gonna want to break open. That's a lot of work. Or you have this method. So all you need to know is how to be able to graph and shade. Boom, and your answer appears. Bang, just like that. You're using the shadow effect to solve your answers or solve your problems much, much faster and even, quite frankly, much more accurate than you would have to do if you're doing algebra. So here it's a fairly plain example. Let's see one question where it's like totally way better to do it this way. Okay, let's have a look at this one. This one you'll like, yep, this is going to work awesome. All right, here's a tasty little question that's probably makes you want to run for the hills. And so if I'm solving it by algebra, I have to solve for each of these brackets. So I'm going to get -3, -1, I got a double root, right? And then I've got a +2 as my answers. So I have to draw out the number line and test each region. So I'm just going to do that up at the very top, and then we'll solve it using the analytic approach, and we'll see how much faster this really is. Okay, so like in a quadratic equation, if this was an equality, not an inequality, but an equality, I just get my numbers, what makes each of the brackets equal to 0, just like a quadratic equation. It's just bigger, right? So these would be my points. And how many, so now thinking about it as an inequality, these are the dividing points between 1, 2, 3, and 4 different sections. So I'd have to get out and I have to test each section into this long polynomial, right, and then see whether I get a true or false statement. That's a lot of work, okay, more work than is needed. So now let's use the analytic geometry approach with the shadow effect and see which ones get shaded and which ones don't, because you might be a little bit surprised. Okay. So if I draw out the equalities, if those was an equal sign, I get this shape. Remember, we got a double root at -1 there, so there's the double root shape. And so this is my shape, right? And now I have to figure out where to shade, right? So this is y is less than or equal to all that. So less than means below. Okay, so when I shade that, it should be everything below. Let's have a look. All right, so there's my shading, right? I've got, to the right and then to the left, and I got this little blip in the middle, but that doesn't actually, well, because it's equal sign, I guess we have to count that point, but it's really this side, that side, and this little dot there. Those are the only things that wind up being on the x-axis. Because remember, I went from 1 dimension with x's to 2 dimensions, so graph xy, and now I want to re-look at what happens when y is equal to 0, because I've done that little substitution. Okay, so what do I have, right? If I was to draw this out as a number line, I have shading to the left of -3. It's up there. I have nothing between -3 and 1 and -1. I do have -1 because this is an equal sign here, so I guess I have to put a point there. That is an actual solution. And then I have everything after 2. So that is my solution. And I don't have to test any points. All I have to do is know how to graph and how to take a snapshot of whatever we're looking at. So just take a look there, and that blue line is the same as what we see there. And if I was to write out my solution, I would say that x is equal to, and I've got a list of things. So when you do a list, x is equal to long bar, and you just list them off. 1, 2, I got 3 things to list, right? X is less than 3. We go x colon long bar, and then we say x is less than or equal to -3, x is equal to -1, and x is greater than or equal to 2. And that, my friends, is your solution written algebraically. Here's the graph. And so, yeah, life is awesome when you do it this way. And when I'm teaching you guys and I'm solving these things up there at the overhead or wherever, or I'm at your desk, or I'm creating questions for you, this is how I'm thinking. And I'm not thinking about just solving it by algebra. I'm like, okay, what does the graph look like? Where am I going to see my answers show up? Over here. Now, the thing is, this doesn't just have to happen at the x-axis. It can happen anywhere. If I change this to a 2, let's say, then I would want to go up to where y is equal to 2, because that's what I'd be subbing in, and I'd want to take a snapshot about what's happening at 2. Now, this isn't entirely clear, but you could, theoretically, if you had a graphing calculator, you could find those points, and that would be simple enough to do. I mean, I could go down to like here to negative, -7, and I could take a snapshot of -7 down here, and I could have -7 up here, and I would, as you can see, I'd have the entire line shaded. So all reals would solve this problem. There's not an x value that wouldn't work, because you can see it down here, it's below, and there's no gaps in the shading. So you can apply it to different different planes where you have the shading effect occur, right? Up here, down there, sometimes you'll have situations where you have no shading at all, and then there's no real solution. So let's have one more look at that. It's very simple. You can start to see why we have answers that have no solution. And really, when you're talking about extraneous values and you get bad answers, right? The reason why you get bad answers is played out in this idea. And really, this idea is the pinnacle of the ideas that you see in the course. Right? We spend so much time learning our graphs, we spend so much time knowing our algebra, and now we put them together in a way, a nice little bow on top of this, to allow you to use one or the other. In some cases, it's just easier to do algebra. But in other cases, it's easier to do graphs. And the more practice you get and the better experience you have, the better you'll be. So yeah, let's have a look there. Okay, let's have a look at that, right? I'm going to add 1 to both sides, take the square root. There's no solution there because you're taking the square root of a negative number. You could write it as an imaginary number if you like, but we can't really graph that. So we have no solution, no real solution, no real solution. So let's see why that is using analytic geometry. Sorry, I had to make this a greater than symbol. All right, so I'm going to graph this, right? Y is greater than or equal to x squared minus 1. So that's that, and everything greater than is up here, right? Boom, 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 right? So that's the shaded region. And then if I see what happens when y is equal to -4, 1, 2, 3, 4. Here's my line. Is there any shading? Nope. So no real solution. If I had it the other way, like I did over here, then I would have this region shaded, and then all reals would be shading in that region. So yeah, sometimes you find things that you wouldn't expect by using this particular style. All right, so this takes you to the end of the booklet, and you're just using these approaches to manage the last little parts of the booklet. Okay, everybody, take care, stay safe. See you later.